All right, let's talk about Albert Einstein. This is a guy whose curiosity wasn't just about finding answers, it literally changed our understanding of reality itself.
Just imagine for a second, what if time could actually slow down? I mean, what if the faster you moved, the slower time ticked by for you compared to, everyone else? And what if space wasn't just empty nothingness? What if it could stretch and bend? Like the whole universe isn't some rigid stage, but something that can be pushed and pulled around by planets and stars. And get this, what if mass, physical stuff, and energy were actually the same thing, just two different forms? Like all matter is just this super concentrated, bottled up energy, just waiting to be uncorked. Now, this might sound like something out of a sci-fi movie, right? But these weren't just wild fantasies. These were the very questions that kicked off a massive scientific revolution. We're talking about ideas that completely tossed out theories that have been rock solid for centuries, ever since Isaac Newton. So, where did a mind like that even come from? Well, to understand it, we've got to go back to the beginning, to his early years, where all this incredible thinking really started. Einstein's journey was, well, it was anything but typical. Born in Germany, he actually gave up his citizenship just to avoid military service, which right there tells you a lot about his independent streak. And after graduating, he couldn't even land a teaching job. He ended up as a clerk in the Swiss patent office. But you know what? That seemingly boring job might have been the best thing that ever happened to him. It gave him the time and the headspace to just think about those huge questions while he was looking over other people's inventions.
And this quote from the man himself, it just says it all. He didn't see himself as some kind of untouchable genius. He really believed his best tool was just this relentless, almost childlike curiosity. That's what pushed him, that passion to just ask why about everything. And all that questioning, it led to the year 1905, a year so unbelievably productive that it's now called his annus mirabilis, his miracle year. Get this. While he's still working as a patent clerk, he drops 4 papers that just completely flip the world of physics upside down.
Okay, the sheer scope of what he did in just 1 year it's mind-boggling. First up, he figures out the photoelectric effect, basically why shining light on metal can create electricity. He proposed that light isn't just a wave, but it comes in these little packets of energy. Bam! The foundation of quantum theory, right there. Next, he explains something called Brownian motion, this weird random dance of particles in water. And by doing that, he gives the world the first solid proof that atoms are real. Then comes special relativity. This is the big one that says the speed of light is always the same for everyone and that space and time are actually relative. And tacked on to the end of that theory was, well, the most famous equation ever written.
E equals mc squared. I mean, we've all seen it, right? But what does it mean? It means energy is equal to mass times the speed of light squared. Basically, mass and energy are just two sides of the same coin. They're interchangeable. This beautiful little equation showed that any piece of matter is just an insane amount of energy, all packed up. And yeah, this is the discovery that would eventually unlock the power of the atom. But wait, there's more. Einstein was nowhere near done. His miracle year was really just the warm-up act. What he did next was even more audacious. He set his sights on rewriting our entire understanding of the biggest force in the cosmos, gravity.
Okay, so for more than 200 years, everyone just accepted Newton's idea of gravity, right? It's this mysterious, invisible force that pulls things together. Simple. But Einstein came along and said, nope, that's not it at all. He proposed something way more wild. He said space and time aren't separate things. They're woven together into this single four-dimensional fabric he called space-time. And gravity? It's not a pull. It's the curve in that fabric.
Think of it like this. Imagine space-time is a huge, stretched-out trampoline. If you put a heavy bowling ball, let's say that's the sun, in the middle, what happens? It creates a big dip, a curve. Now, if you roll a smaller ball, like the Earth, nearby, it doesn't get pulled by the bowling ball, it just follows the curve in the trampoline. That's gravity, according to Einstein. There's this fantastic quote from another physicist, John Wheeler, that just nails it. Space-time tells matter how to move, matter tells space-time how to curve. It's this perfect, elegant dance. Mass and energy shape the universe, and the shape of the universe tells everything how to get around. And that was his general theory of relativity.
So this is a totally mind-bending theory, but was it actually true?
Well, in 1919, a scientist named Sir Arthur Eddington led an expedition to watch a total solar eclipse. The plan was to photograph the stars right next to the blotted out sun, and what they saw was incredible. The starlight was bent, warped by the sun's gravity in the exact way Einstein predicted. When that news broke, it was an absolute sensation. Albert Einstein wasn't just a physicist anymore. He became an overnight global celebrity, maybe the first science superstar ever. But see, Einstein's story is so much more than just the science. All that fame gave him this massive global stage, and he wasn't afraid to use it. He became a powerful voice for his deeply held beliefs about humanity, peace, and justice. So, in 1921, he gets the big one, the Nobel Prize in Physics. But here's a fun little piece of trivia for you. He didn't win it for relativity, either special or general. The Nobel Committee was still a bit skittish about how revolutionary those ideas were. Instead, they gave it to him for that 1905 paper on the photoelectric effect, the work that helped kickstart quantum mechanics and, is the basis for all our solar panels today. And, of course, the world's turmoil didn't leave him untouched. As a prominent Jewish intellectual, he had to flee Germany when the Nazis came to power. And then, despite being a lifelong pacifist, he faced this terrible choice. He signed a letter to President Roosevelt, warning him that the Germans might be working on an atomic bomb. He was terrified of what would happen if they got it first. It was a decision that would haunt him for the rest of his life, and he spent his later years fighting with everything he had against the spread of nuclear weapons. And he didn't stop there. He was a huge proponent of a world government to stop future wars. When he came to the U.S., he became a really vocal supporter of the civil rights movement, joining the NAACP and calling racism America's worst disease. He was also instrumental in establishing the Hebrew University of Jerusalem. In fact, in 1952, he was even offered the presidency of Israel, which he very politely turned down, saying he just wasn't cut out for the job. When you look at his whole life, it's clear his incredible intellect was matched only by his conscience. He really understood that with great knowledge comes great responsibility. He knew that the same mind that could figure out the secrets of the cosmos also had a profound duty to care for the people living in it. So, in the end, Einstein's legacy isn't just a bunch of equations on a blackboard. It's his absolute, unshakable belief in the power of curiosity. He showed us that asking the biggest, boldest questions can actually change the world. And that really leaves us with one final thought, doesn't it? If one person's passionate curiosity could literally bend the universe, what could yours reveal?